what I forgot. I did not get it. It's in the garage. I have to go get my yeah, because my the thing that I use to measure stuff, it's out. Well, first of all, it's at school in my office. So I have to run out my garage real quick and get it. But if you want to, you can find your photoresistor in your kit so you can work along with us. So give me a minute. Let me go run out and get it. It'll be about maybe 1 minute, 2 minutes probably. It depends. The garage is pretty messy. So let me go get that. I'll be right back. All right. So luckily I have luckily I found it. It wasn't too bad. Okay, so what we have to do, well, now I have to find them. Gotta find the thing here first. Where is all my? There we go. Now we're cooking. All right, so let's see if we can find this bad boy. I don't know what package it's in. It look like, yeah, there it is. It's in with the buttons. Yeah, and I have 2 of them. I don't know how many of you guys. All right, come on. Now I'm just gonna dump all this stuff out. I want this one. There we go. Ay, ay, ay. Okay, so here's our component, right? So it looks like that. Now, what I want to measure is I want to measure the resistance of it, right? So I'm going to turn my DMM to resistance, and we're going to see what that is. I don't know if we're going to be able to see everything here. It'll be sideways. Right, so if I put those things together, I got 0. Okay, and now what we're going to say is if we measure this, that's just fell over. Come on, piece of garbage. And if you had a difficulty with the resistors, or I'm sorry, the resistors, this is even worse as far as having these cables, these little wires bending on us. Okay, so if I look here, right now it's at 10.5K or 10.56. And then you can see what happens is if I put my finger over that, you see how the resistance changes. So when the resistance changes, right now it's at 132K or 130K, right? And then you can go the other way because like right now this is ambient light, around 10K or so. If I turn on, you got me a giant flashlight here. So if I turn on this bad boy, you can see things really get lit up. And if things really get lit up, it should be less, right? So you can see it's at like 0.6. So we're going to care about that. And now if you don't have, if you don't have a nice flashlight, like I don't want to show you the flashlight because it'll blind you. But you can see how bright this thing is. This thing's like a monster. You can use your cell phone, that should have a flashlight on or some other kind of light source because we're going to care about the uppermost values, right? With like no light and then the lowest values with a bunch of light. Like that's what we care about. All right, let's get back to this. Oh yeah, and the other thing that's cool about this, there's no polarity on it, so it doesn't matter how this is hooked up. There's no positive, there's no negative, right? It doesn't matter if you're running positive voltage on one side or positive voltage to the other side. What we care about is what the voltage drop is over the photoresistor. Because think about it, guys. Just with the potentiometer where we're increasing or decreasing the resistance of it, that made our LED brighter or dimmer. And we can, essentially we're going to do the same thing with this. Okay, so I needed to actually write those values down, the ones that I observed somewhere. So we'll start with a middle ground, which again is ambient light, which the ambient light in here is actually pretty bad. And it was around about 10K, depends on if I'm over the shadow. So if I'm over it, then it's 10K. Yeah, that's what we're gonna say. So 10K is our middle ground, ambient light, or you know what, why don't I just do this the right way? Nine. So let's say 9 is our middle. So I'm gonna write that down somewhere. I don't know where, probably in Notepad. Okay. All right, so that's ambient light 9K. And then I want to measure what is if I cover it up. All right, something like this. And that jump to 66K. So it keeps going 65K. 65K. No light. 65K. And then a giant bright light. Let's see what this looks like. All right. And that says it is at 0.6 kiloohms. Okay. 0.6 kiloohms. Bright light. Okay, so again, that's what we got. So I have ambient light 9K, no light 65K, and then bright light 0.6K. All right, so did it. That's it. That's the lab. That's all you guys have to do for the lab.
So are all of ours going to be different, or are they going to be close to the same? Because I'm getting like 300K when I have no light on it.
Yeah, it really depends on. It depends. That's why you have to measure this because it is going to vary depending on because the tolerance on these is variable. This is why you have to measure it first. Not only that, but then also how good are you at covering it up? I mean, if you're really covering it up, then you're good. Like I said, the outside too, you can see the outside on these are not, you can't really see, that's blurry, but the outside of these guys is not shielded. So then you're going to get light from the outside coming in. So yeah, they are going to vary. And then I don't know if you can get higher. I bet you guys can't get higher than that because that is like the super. This is so bright. It's like insanity. See, can anyone get lower than 0.6K kiloohms? I think you'd be hard pressed to do that because that is this is an awesome light. It's a Makita. This thing is like actually that battery you can use to run a vacuum cleaner. Oh, and the LEDs on here, like here, everyone look closely into the screen right now. All right, cool. All right, I'm gonna write those down, and then I'm gonna write it down a chart to save for later. And really, it just has to do with this. The chart is this. What is the? You might want to do it this way, just so it kind of makes more sense, I guess. Well, like high and low values, if that makes sense, like this. Something like this. Okay, so some nice chart that says, okay, there's no light. This is what I'm reading. This is what the ambient light is without me doing anything. My shadow is not covering it, because a shadow will, you can see how it changes the light, right? If I just put a shadow over it. So make sure you're doing the same measurement every time. And then a bright light. Now, what we want to actually do is look at our friend, this voltage divider formula. And this is available on Moodle. So if I go to Moodles, right here for module 3, actually I have it, it's a link right here. So voltage divider calculator, it should take you to this spreadsheet. It is shared. Anyone can open this. I don't know, right? You can modify it. You can see it was modified, well, it looks like just about a year ago. So imagine that. And, this is what we have to change, are these values here. Now I'm going to talk about this in just a second. But we're going to need this resource. Now, I'm supposed to draw this, but I am just not going to, because I don't have the time. Yeah. Okay, so I don't know why that got messed up, because I have two of them behind it. What in the world? But at any rate, this is this is how we hook it up. So if we look here, right, here's our photoresistor. And the way I hook it up is I hook one end to ground and I hook one end to voltage in, right? Now, I don't want to, this is the thing we have to figure out. And that's what we have a formula for. So don't really worry about this, but usually it's right around a 10K ohm resistor. So V out goes to like our measurement, just like with our potentiometer, right? We would hook it into one of our analog inputs. The ground, 5 volts, good deal. Okay, so then we want to wire it up. So now if we're using this as a guide, we want to wire it up. So looking at this, it's not too bad to wire up. So let me go through and do that for us. Where's our camera? Here's our camera. Okay. So we've got this here. And all we want to do is get our 10K ohm resistor. Oh, that is. Ho, 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 ho. You gotta be joking me. I thought I did. I like prepared. I had all the stuff here, but then it's like these little nuances I don't have, because I ran.
Wouldn't you have one with your potentiometer one? That one had a 10K resistor with it. So the stuff you ripped off the board just a little bit ago.
Yeah. So if I turn it all the way up, you mean? Oh no, that was two 100s. Oh, I see what you're saying. No, that was two 100.
Oh, you had two.
Yeah.
I thought. Maybe. I mean, I guess you could use the potentiometer. If that goes to 10K, can't you?
Yeah, but then I have more wires to worry about, and that just looks confusing when I don't need to do that. I have resistors out. Again, I have them out in the garage. Jeez, oh Pete's. Okay, let me run out in the garage again. I know where they're at, so it'll be quicker. So give me a second. Again, what I would do is, this is what you want to wire up. So you can look at this and, you know, A0, 10K ohm resistor. So wire this circuit up. I'll be right back. Give me 1 minute. I have to mute this. So okay, so now I got my business out. The only problem is I don't have memorized my bands, what my color bands are, but the first one should be black. Should be maybe black, or is it blue? Gosh darn it. So, because I don't want to have to measure, like, I don't want to have to try and measure 100 of these. Let me try this.
So I don't know if ours are going to be the same, but it's like brown.
Yeah, brown, black.
Both ends, I think, are brown.
Yeah, brown, black. Okay, cool.
Yeah.
So yeah, that's gonna be our guy.
It's like brown, red, black, black, brown, or something.
Well, no, wait, mine is. I'm gonna measure this again. No, that's it.
Yeah. Oh,
All right.
yeah. Yours is a completely different color than mine. Like mine's blue.
Well, yeah. So these are a different grade, and it has to do with the resistance or the tolerance. You know, like I said, there's different quality components, if that makes sense. Um, and unfortunately, the blue ones are just a little bit cheaper. These are like my own. All right, so let's wire this bad boy up. So it looks like this, right? We're gonna do that. We're gonna do this, and then we're just gonna put one end into our 5V, and then this end's gonna be our measurement. So orange is gonna be our measurement for A0. Geez, I don't need it to be this long. Okay. And we'll just do it in A0. All right, cool. And then that's going to go 5V. I guess if I kept it on this side, I don't have to worry about it. And then the other guy is going to go on the ground. All right. There and there. All right, so that is it. So that's how we wired up. Now, we want to put some stuff in our IDE. So let's open up our IDE, and I can just paste it in the chat, so that way you don't have to type everything. Because again, this is just for testing. So I'll put that in there so you can just copy and paste it. And it does it nice and formatted for you too. So isn't that just fantastic? Thank you so much. So you can see what I'm doing here, right? So every time I go through my loop, I'm declaring and then initializing the value of sensor value, the variable, based on what I'm reading from a 0. And then I'm just going to print out that value, and then I'm going to wait 100 milliseconds. So pretty fast, right? So we need
real quick, to clear out the old code from like the potentiometer, you just do just an empty setup in loop, right?
Yeah. So,
Okay.
or yeah, and that's a good point. I should really take off the 5B here, just so that way I know that nothing's going to really happen. Even if I output something, it doesn't really complete a circuit, so I'm good. And yeah, that's a good point. So I'll do that because who knows what was on there before. So I should probably verify this first just to make sure it's good. Make sure I have, because this will, everything's good here, right? This stuff shouldn't change, but again, if you plug into different USB ports, or if you use a different device like I do quite often, that stuff will change for you. So you have to go in and select it. All right, so then I'm going to upload it. And once it starts doing its little flippy flack, we're good. All right, so I'll put this back in there, 5 volts. All right, awesome. Okay. So now we can open up our serial monitor, and we should see some stuff getting kicked out. And then we know like what our values should be, right? So right now this is ambient light, right? And then the whole idea is what happens if I cover it up, right? That goes up to, I don't know, 850. We want to kind of get a good idea. So if I cover it up pretty good, 850, so I could get 850. So again, just like we did, and then I do bright light. Bright light, see how it doesn't go all the way down? It's like around 40, right? So again, I care about those numbers just like we did when we were measuring the resistance of our photoresistor based on, move this out of the way, just like we measured our resistance of this with those 3 types of environmental conditions. We're going to want to write down or, keep track of those values. Now, so what would happen? Nothing would really, well, let's see. Right now we're at what, 480-ish. So what happens if I just flip this bad boy around? Right, and where we had that going low, right, with the light going high, covering that up. You see how there's no polarity here. So it doesn't matter how you hook it up. It doesn't matter, which is different than our potentiometer. That did matter how we hooked it up. If we had positive going on one side and negative in the other, right? That's how we flipped our values. With our photoresistor, it doesn't matter. So good deal. All right. Well, now we have to do some math, but like I said, it's pretty nice because the math, I mean, we should know how to do it. It's not going to affect things too much, especially if we do like extremes, but it's something that we should be aware of. And that, again, I have to mention it because it's just referenced a lot in circuits when you build stuff. So let's say this. Let's say you're, for your final project for this class, you're working on something and it requires a voltage divider formula in order to determine what type of resistors you need, which is very common, especially when you're talking about environmental things, because it varies based on your environment. Is it really cold in your room? Is it really hot in your room, right? So we need to have a little bit of knowledge on this, because you will see this referenced. So this is why we have to talk about this guy. So you can see we have the same setup here that we have right now, but we are trying to figure out what our fixed resistor should be. So, again, there's a formula that allows you to calculate the V out depending on the value of your photoresistor and your fixed resistor. Because just like Devin, you said, hey, I'm getting different values. So you're going to need to make sure that we match up this resistor as close as possible. And again, R1 and R2. Now, R1 and R2 let's go back to this. Here it is. R1 and R2 are these guys, right? So if I'm looking at this is R1, this would be R2. So we're trying to figure out, well, what do I need to make this so that way basically my circuit here is balanced, is what I want to really do. And in all fairness, this is really what this functions as here is a pull-up resistor. But at any rate, this is R1 and this is going to be R2. How that maps here is R1 is really Z1 and R2 is really Z2. I don't know why. I mean, maybe I got this from somewhere. I don't know. I should have probably given it credit where I got it, because I don't know where I got it. But at any rate, let's go to these guys. All right, so we have this chart back here, what we wrote down a while ago. And based on these values, we can use these in our formula to figure out what our R1 should be, because R1 is our resistor, R2 is going to be our photoresistor, or Z2, whatever you want to think of it, however you want to think of it. So we're going to go here. We want to figure it out for ambient light. Okay, so whatever this ambient light is, and it happens to be just around 9K, well, we go back to our voltage dividing formula here, and we put it at 9K, which would be 9,000. Right? And you can see that the V out is 4.21. The goal is to get this to be at 2.5, because again, it's a voltage divider formula, right? So if I go back here, voltage divider should do exactly what it says, which is divide the voltage. We know that there's 5 volts coming out, so half of 5 is 2.5. That's why we want to have the reading here at 2.5, right? We want half of it to drop over the resistor, and we want half of it to go out. So we have to use this to calculate that. Now, VN should stay the same, 5. And so what should I put here then to get this to balance out? I don't know if whatchamacallit shows a formula. Oh yeah, it does. Look, there's a formula. So based on that formula, here's back to math class. This is what it is, right? This is the same exact thing as that down here, right? So what value do I need to put in there? What if I put 5,000? This value should drop, but it didn't quite drop enough. What if I put 7,000?
We're just putting our 10K resistor in there, aren't we?
Yeah, right. But you saw with again, depending on the ambient light, because like I said, it is a little darker in here. You may have different values that you're working with, depending on, again, depending on your environment. So you can see that 9,000 is going to work out just fine for me to get my 2.5 out. So essentially, whatever you're measuring here for R2, it's going to be the same thing for R1. Okay. And again, the R2 and R1 is for this. All right. R1, R2.
So if we have more than 10,000 ohms, we're going to need to add more resistors.
Yeah. So if it's at, like, I think, would you say yours 9?
Mine was at 300,000 or so when I covered it up.
Yeah. So you maybe have a desktop light, a lamp up, or something, or, you're in a really dark room. So depending on what it is, you can just figure out whatever you're measuring is typically.
Well, the 300,000 was me covering it up, not the ambient light, I guess.
Oh, okay. 300,000 would be the higher, yeah, if you're covering it up. But then what is it if you just have no light? You know what I mean? If it's just like, if you have on, I don't even have a light on in this room. So that's pretty much it. So, do you need to use the photoresistor or the voltage divider calculator? Really, you don't, but it's helpful if you have, if I have different, if I had this, well, I know that that's going to be still half. You know what I mean? So no matter what it is. Okay, so that's that. And I hope you're not putting any comments up here. There's a chat in here, so you can chat the voltage divider calculator sheet if you'd like to. I encourage you not to. Now, 9,000, is that pretty close to 10,000 or 10K? And again, if you guys aren't familiar with math, then I don't want to say it's not a big deal, but if you're like, I don't really get how we are figuring out that this is a 10K ohm, because this is in units of measurement, right? So all we need to really worry about is like kiloohms and the base unit. We don't need to worry about mega and nano and all these other different types of measurement. And again, just a FYI, if you want, you can say, what is it? Scale of measurement. Unit of measurement ohms. And hopefully we get a nice little chart here. No, it's just going to tell me ohm. It should be scale, unit of, or scale of measure. How about this? Milli, mega, pico, all those, giga, metric prefix. Yeah, so you may have seen these. It's the same idea, right? Now, you'll see that there's nothing in the middle here. Like, what's in the middle? The middle is your base unit. That's your base measurement. So that's why it's 3 up or 3 down, right? And what do you mean by 3 up or 3 down? We're talking about, the amount of zeros we put on here. So do you see how this is measured in 1,000s? So when I say 10 kiloohm, or in this case, if I say 9 kiloohm, right, we're really saying 9,000 ohms. So I hope everyone sees that. If it was like 0.3 or 0.003, right, the unit of measure would be under a volt. But at any rate, the point is that it's 1, 2, 3, 1, 2, 3 from the decimal point. Again, this goes back to, I think we learned this in like moving the decimal around, probably in middle school. So at any rate, this is all that's talking about. So when you see these references to different, prefixes or measurements, that's all we're talking about. So now that we have our math lesson in for today, let's continue on, eh? Okay, so now the idea here is to place the correct resistor in the middle, right? And if, again, like I said, if I was really good, I would put 9,000 in for, sorry, 9,000 in right here. This is 10K. 1,000 ohms is pretty substantial. So, but how do I get 1,000 if I'm only have, you know, I might have, I don't know if you guys even have a 7.5K ohm resistor in that kit. I don't know if you do. You know, but if you did a 7.5K, you did two 1,000 ohm, right? I would get closer to my 9,000. That would be like 9.5, or I could go on the light side, light side. You know, I can go on the other side and say 6.5, and then I could throw in some 330s, some, you know, 200. I mean, there's a whole bunch of combinations that I can use to get to that ideal number, but in all truthness, close is close. All right. That's why you saw I wired it up with a 10K to begin with.
Yeah, we got 5Ks and 1Ks. So
yeah, 5Ks and 1Ks are, yeah. So 1,000. So if you did 5 and you did 4 more, boom, you would have, if that's what your number is, 9,000, you might have 12, you know, 1,200 or 12,000.
there are 10Ks as well.
Yeah, I think everybody's pretty cool with just using a 10K. For this photo resistor that we have. Other ones, it might be different. All right, so then, and measure value way halfway through. Okay, so now we should, okay, so here's what we'll do. We're still running this, right? This guy's still running. Now we got to think about this, gang. Get my calculator out. And 1023 divided by 2, 511. So it's a, you know, it's a little bit high, right, for being halfway in between 1023 and 0. So again, I would actually have to pull off some resistance there to lower that number. That's why it's reading it a little bit high, if you will. So I could do that, but like I said, that would require me adding a bunch of these things in, and would it take me like the rest of class to get that figured out. So we're not going to worry about it. We're just going to know that that's kind of the halfway point there. It's pretty close. And that's what we want with ambient light. And we already did this. We already did it, right? So it doesn't quite go all the way down to 0 there. And should go up pretty high. I can't get it above 900, it looks like. But we know we could map that value if we wanted to. But close is close. Now, here's the cool thing. And I mention this because this might be something that you want to do or use, because you do have it in your kit, and it's called a thermistor. And what the thermistor does, and you could look at the top of your chart with the pictures, and you should see, it just looks like a little, you know, it just looks like a little, you know, it's hard to explain, but you can see the picture. It looks just like a little flat piece of something. The thermistor is really the same exact thing as this, but instead of measuring light intensity, it actually measures temperature. So it'll measure hot and it'll measure cold. So there's a thermistor. You can look at that. Maybe you want to use that if you just want to worry about temperature. But what I want to end today talking about is our next, our thing that does temperature and humidity. So before I go on, is there any questions about this stuff? You know, with the photoresistor, you have values, you want to measure them, because we're going to use these numbers later. We have a lab on this. The lab looks like this. Put back here. For this lab, you will control the intensity of an LED using a photoresistor. Now, I set this up. Okay, so this is the lab that coincides with what we had just set up here. The brighter the light is, when the brighter the light is that the photoresistor picks up, the LED will diminish. Okay, and then in intensity until it's completely off. And then conversely, as the light is picked up, so if you have wait, as the light picked up by the photoresistor gets darker, the LED should gain in intensity until its maximum intensity. And that kind of makes sense. That's something that you would probably want to do, right? If if there's no light, then I want my LED to turn on more versus the other way. If I have a bright light, I want it to just maybe turn off, right? That should make sense. So we know to adjust the brightness of a LED, we have to hook it up the way we did last time, meaning the LED, which is, I have to have some way to adjust the pulse width modulation of it so I can make it brighter or dimmer, and based on those values, right? So we have one of two things. Since we have all this stuff out, maybe we should just look at this lab right now, or we could continue on and look at some other types of measurement. So let's do a vote and see what you guys would like to do. I will put it up here in our, you know what? I don't think I can do a chat. Oh, you know what? This is how I do it. Under post. Oh, because I'm under the wrong module. So this way everyone will get a chance to, there we go. I'm gonna have to create a poll on my sketch. Okay, so question. All right, let's go ahead and do that. So if you go back to, I don't know if it's in the chat or somewhere, if you guys can find that, and you just click on one of the options and then hit submit vote, right? So it'll look like this. So you have to go back to this screen, right? And you make a selection there, and then you just hit submit vote. And I think that works out nice. So getting a live update, it looks like one person's responded. Got to keep in mind, we have till October 26th too. So we have like a while, but the other labs get a little bit complicated. So maybe we want to knock this one out first. I don't know. Only one person says work on the first lab. That's it. I have one response. Is no one else going to respond?
Uh-oh.
Is it just lagging or something? Just 4 others replied. So my phone is actually faster than the app that's here. Are you kidding me? Okay, we got 3. All right, that's good enough. Because that's like half the class anyway. All right, so let's do that then. Let's look at this and let's see what it is. This way too, what I would strongly recommend, because I think somebody had already told me like, oh shoot, I forgot to download the videos and I don't know, so I know Devin, you were doing some stuff with uploading them and whatnot, but you guys want to make sure that, you download these videos because you may need to refer to them 2 weeks from now. 2 weeks from now, you would still be under the threshold of 20 days, but right. If you want to refer back to something we were talking about way back in chapter, well, we need when there's no chapters, but way back in module 1, you know, you might. So that's up to you to manage that. I mean, I could always meet and talk about it, but you know, it's kind of like it's already there. All right, cool. So let's look at this. So let me open up a couple things then, and we will we'll at least wire up the lab so we know what it looks like. And this is a module 3, and this is what the thingamabob should look like. So here's a picture of what it looks like, right? And yeah, now I can already see what I did here, right? Because, well, and it's hard to see it, but behind here, you know, there is a 330 ohm, right, resistor. So 3.3 volt resistor there, 330 ohm. So I'm going to probably need that guy. And like I said, I could probably find one for me. And it looks like when I did this, I had some different readings for ambient. So that's probably why I have 2 of these guys in there. But this is what we want to do. I'll wire it up. You know, you should be able to follow everything along, right? So this is obviously going to ground. This top one, that goes into ground. This green wire, that goes into the blue side of here. Ground going into one side of my photoresistor 2. And then here's my measurement. It looks like A1 I chose, and then 5V in goes here, right? So, and then to control the voltage out to my LED, I have it connected into, it looks like 6. But either way, you can see which one it's on. It's on the squiggle, right? So I'm probably going to do some fun stuff there with that. All right, let me stop sharing my screen for just a quick second. Okay, I guess I didn't need to. But what I wanted to do was make sure that I didn't give you the answers, right? Because that would have been pretty crappy. Then you would just see the answers and be like, oh, well, I'm just going to copy and paste that. So take a minute, wire up everything based on what you see here, and then we'll continue on. And if you want to listen to some music while you do that, it might take like 3 minutes or something. Or it could take longer. You know, I already have everything kind of set up, so I'm just going to keep building mine out. So I need my LED. And I'll mute my mic so you don't hear me rambling, because I do a lot of rambling. What are the different resistor strengths again? Resistor strengths. Okay, Michaela, you're talking about
Probably the ones on the left.
these. It depends on what your ambient light is, because otherwise your intensity, your LED is going to be off. So for me, I'm just using a 10K. Most of us probably would be okay using a 10K. But again, if you use anything else, you're going to have different readings, if that makes sense. Like on your A0, in this case, A1. So again, 10K would work. I would say 10Ks would be pretty much fine for most of us. So 10K, and then this one is the 330, yeah. The other one's a 330. Okay, so this goes into positive. And this way. Okay, well, I just realized the crappy thing with this is that, well, I'll get a different flashlight, but the flashlight becomes so bright that you cannot, it blurs out, it whites out. So let me see if I can find a different one.
Question: the photo you had of the PowerPoint presentation with the wiring up, is that
Yeah.
on the Moodle?
No, because here, it's the same thing as this. So it's like, you can just look at this. It's the same thing, just a different perspective, if you will. Right. So, I guess the image is fine to share because that's mine. But at any rate, what I wanted to do is, I can just put it up there real quick if you want to refer to it. All right. And so if I go here, well, heck, I can just here. Why don't I just attach it in here? I'll just put it in the meeting. Go. Look at that. All right, cool. So it'll be in the meeting chat. The image will as soon as it uploads. That way it's like instant access. You don't have to open up Moodle. It's still uploading, so I don't know how long that's going to take. But at any rate, this is a little bit. Yeah, this is what I'm going to do. I'm going to bend this over so I can do this without. So you see how that works, right? As the light gets brighter, it'll go to all the way to where it's turned off, right? So again, kind of nice. Now, if I want to get it darker, it should get brighter. Well, just make sure you're not shorting it out. Okay, so if I do this, it's like it's so can't see it that much because again of my 10K. Now, what I'll need to do is, I got it. I know this is why I did this earlier. So you'll see that it'll be a little bit more responsive. And that was the high and low values. Now, crap, I forgot to write down what my upper bound and my lower bound was. Okay, so this was around 540, and this was around 40. I think my upper bound for my bright light. All right, so I have to figure this out. What was it? I think it was lower. So I'm going to change this. Okay. Yeah, it should get dimmer as I get more light on it. And if I cover it up, it should get brighter. So what have I broken now? Let's go with 9 there. You can see it's a little bit more responsive for me. Now, what you do want to make sure of is that when you are covering this up, right, that you don't, you don't want to you just want to kind of touch the top of it. And if it's kind of blinking out for you or stuff like that, it's most likely because you have a loose connection, right? So that's what we want to simulate. If I cover this up, better that goes. All right, so now let me go a little bit higher. Okay. hopefully should be more responsive. And again, I have to kind of play around.
So if we have 2 resistors for our photo resistor, because mine was 20K ambient light, so I'd have to put 2 10Ks on there. Am I gonna have a third resistor for the LED?
Yeah, you're gonna need this is the this is this 330. Yeah, and that is hooked up to the, in this case, it's the anode end, because I put the cathode end on this ground here of my LED, so it just goes right to ground, and then so I have to have that resistor over that going to the power, which is out of pin. In my case, it's 6. The 6 is down here. And again, one of the biggest trick here is making sure that you hook, well, not the biggest trick, but one of the things is to make sure you're hooking into one of the pins that, again, I can do pulse width modulation over. I can simulate an analog signal, make sure that's in there, because remember, the values that I can kick out to an LED, right, to adjust the pulse width modulation, that is in a range of what? So what we're talking about here is, now with the photoresistor, the potentiometer, we had to use the same strategy, which was using the mapped function, right? And I think most people had the most difficulty with that. Here again, you're going to need to use the map function. And what are the values that you're mapping? You're mapping what is the low side of, reading this versus what the high side is with the light, or actually the other way around, right? So the more light you have here, the smaller the number, right? And it should go to where the LED turns off. So again, you're mapping values. And again, it's hard to see this. Well, I have to do it this way. Oh, here, I'll just put it down like this. All right. And then if I shine it this way, it doesn't, right? So you can see it turned off. So you need to map the values. So that's the biggest thing with this lab, is you have to use the map function again, and you need to map low numbers to, low numbers of your of what number you're kicking out to pin GPO 6, right? So the low number here that I'm reading for my photoresistor should be the low number here, and that should go all the way down to off, which is 0. So you should have 0 out as this number is at its lowest value, versus the high value, whatever you read at your highest setting, right? Whatever you read at your highest setting, you want it to be, that high number. And again, if you're not sure, you can always go back and do this. Right, measure the resistance. So at ambient light, I'm at, again, I guess you can't see that, or you see a bunch of other stuff. I don't know how I did that. All right, so I'm measuring this. I can see that at ambient, I am at, well, what did we say? I just made a mistake here. If this thing's already in the circuit, I really can't, it has a different resistance. So I have to physically disconnect it if I want to measure resistance. So if I wanted to see the high and low values again, and I needed to write those down, and I didn't. So I'm just going to do those. All right, something like this. All right. Get you on there and get you on there. Well, now at this angle, it's like 53, but we said 50 kilo ohms. So, now it's 9. But again, I guess I would need to be measuring what A0 is. So you can write out to that. All right, that'll work. So I'm going to combine what I had put up there before, and I should have pasted in too. Okay, cool. So I'm going to put that in my code. that, and all right, let's upload that. So I'm going to give you everything that you, I don't want to say everything you would need, but there you go. So now I'm reading the A0, but see now if, hold on a minute, I don't have it in. Okay. So that's ambient. It's like around 400. Now, if I cover it up, right, that should go up to whatever my maximum value is. But think about it, guys. If this goes up to my maximum value and it's turning on the LED, what number do you think I should be writing out to it? A high number or a low number? And the high number or low number is that the high and low value is 0 and the high value is 255 for, again, writing out to GPO6. So if I'm covering this up and I'm getting a high number, what should that map to? 890.
So you're saying for our map function, we need to do like 0 to 890, and then what we do, and then would the just 0 to 255 stay the same?
Yeah, 0 to 255 would be the same, but again, now I need the inverse here. That's wrong. Hold on. Actually, this was better. Okay. So then I need the opposite, which is, what is the reading here? Well, I'll load my sketch again, so hold on. All right, so if I have this, and you see how that goes down to right around 40, right? So right around 40, what should that map to? What number should that map to? Should that map to 0 or should it map to 255? If it's turning off. Or it's decreasing. Do you see that? It's decreasing as that number gets lower. So what should that map to? Again, should it map to 0 or should it map to 255? You want me to do a poll? Well, again, I'll just tell you. So if that gets lower and my LED turns off, talking about pulse width modulation, I want that number to be lower. So I want to map to my lower number. It's just like I'm re-specifying, if you will, the boundaries, right? I'm mapping the boundaries instead of being, I can't get this to 0, right? No matter how hard I try, I'm not getting this to 0, but I want it to be 0, right? So if I want it to be 0, I have to remap 40 to 0. Conversely, if I cover this up, right, and I can only, get 950-ish, right, 950-ish, then I need to map 950-ish to the highest value, which is 255. Again, that's what pulse width modulation is. Adjusting the intensity is, I only have numbers, 256 numbers, so 0 to 255 on this. Again, if I put it at 128-ish, something around there, my LED should be at half its intensity, although mine's a little bit skewed. And again, it's because I'm not using the proper values, or the proper whatchamacallit. Boy, it looks like a bunch of people are dropping off. We've lost 2. Okay, so that's probably because they're like, that's fine. So I guess before everyone leaves, is there any questions about this? This is really the lab, and the biggest challenge is figuring out the map value, and then after that, it's just logic.
I'm pretty good with it. I already have everything I think is wired up correctly, but I guess we'll have to test out to see.
Yeah, wire it up, test out. It might take a little while. And obviously the big part of this is doing the programming. So let me know what you need, as you're working along. If you have your code, just copy and paste it, shoot it to me. Please don't send me a screenshot of your code because then I can't input it to use it without me having to type it all in. So just copy and paste it, throw it in an email. I'll look at it. I'll give you a video back and I'll wire. And then if you can, do include a wire of a picture of what you have here, right? Or like I said, make a quick video that says, hey, here's everything. I think that would be helpful because everybody's gonna have to talk about this stuff when they present anyway. Okay, guys, I'm not gonna keep anybody. And you know what? I noticed that my clock on my that's why people dropped off. My computer time is off. So if you haven't noticed that, it's off by like a couple minutes. So that's why, mine just now says 10:50, which really is like 10:51 or 2. Okay, so I'm going to end it there. Again, keep in contact with me. Let me know on, well, this is Thursday. So next week, we'll be continuing on.